Before I begin, today we are going to look at arrays from the beginning. So we will also, in short, revisit the time complexity so that you get more familiar with it. So how many of you watched the video? So we have like 1, 2, 3, 4, 5 of you in call. Did you all watch the recorded content uh, which is given to you in the eLearn short videos? Yes or no? Yes or no? Those who are there in the call, please answer. You can just type your answer in the chat, or you can also give me, get them unmute and answer. Yes. Are you able to, did you all get the access to the LMS and you have all the videos available, right? No? Gokul, Saujanya, Asha Devi. You haven't got access?
I'm able to open the portal, ma'am, but not able to watch the videos.
Is it possible for any of you to show me the screen, eLearn portal screen?
Yes, ma'am, but no, can you give the access to share the screen?
Yeah, definitely.
I'm able to see my screen.
Yes.
Yes, ma'am.
Hmm.
So here, this is showing. Actually, this is not my personal laptop, ma'am. This is my
Okay.
office laptop.
Oh, so any of the videos you're not able to see?
Yeah.
Okay. What about in your mobile?
Check it once.
So just show me one more video in this video algorithms and data structure. Can you open that video which is there in introduction?
This one, ma'am.
No, okay, that one also. So every video is access denied. So is it the case for every one of you or only few of you?
Ma'am, in HCL laptop, it is access denied, but if we are using personal laptop, it's we have access on that.
Okay. So didn't you try to initiate a request with the IT team to get this enabled for watching videos? Did any of you try? Okay, I will speak to the team so to see if this can be enabled. But apart from connecting with HCL network, are you able to access it elsewhere?
Yes, ma'am.
We can access through mobile, ma'am.
Okay. And personal laptop also you can access, right?
Yeah.
Okay. So if you connect to this personal laptop in your HCL laptop in your house, are you able to connect?
No, ma'am.
Then also you'll not be able to connect. Okay.
not at all accessible in the system.
Okay, okay. So it is not network whitelisted. It is like the system also has permission issues. Okay, fine. Can you send me the snapshot of this image over email? I will talk to the IT team to get it enabled for you. Okay.
Yeah, this snapshot, right, ma'am? Showing
Yes.
the access.
Yeah.
Okay.
Yes, this complete snapshot. Maybe you can do a full screen and just give the entire details.
Yeah, sure. I'll share it to
Maybe
you.
you can mask your ID if it is there, if you want
Okay.
your name or something, and just send it. Okay. Okay. Thank you, Saujanya. So we will get it enabled, but it is very important that you watch. It is not very big videos. It is 10 minutes, 15 minutes, maximum like 3-4 videos. So please start watching it. It will be very useful for your learning. Most of you do. I have seen past recording views and all. We track of how many hours you have watched, etc. So the previous semesters and all, I see that most of you watch it during the exam, just before the exam, etc. Which is also good. It is provided for you to prepare for the exams also, but make sure that you watch it before the class or a weekly segregation so that you can get the context more clearly in the class, and you can also learn it well holistically, because when you learn just before the exams, you tend to miss uh, vital information which are not important for the exam point of view. So ensure that you watch. They are not very big videos, and also it will not take much of your time. So you can for sure make sure that it is done. So this class we are going to erase, and from next class, we will have the labs enabled for you. So we will have the lab session starting from next Sunday. So GCC compiler will be used. How many of you have used GCC C compiler or any C compiler? Leave GCC. How many of you have used C compiler? Okay. All of you, did all of you do labs in computer programming in the previous semester, first semester?
Yes, ma'am.
Oh, sorry, in the previous semester,
Yes,
second semester. Yeah. How did you do the labs there? Which portal did you use, or you had your own compiler?
Ma'am, they provided Newbie Pro virtual machine, so we'll
Okay.
go there and save the file and run in the terminal.
What was there in the terminal? GCC compiler was there, is it?
Yeah, ma'am. Yes.
Okay. So I will see similar for data structures also if it is given. Okay. So in between, if you don't get, we'll start the labs from the next session. We will have a lab faculty who will start teaching you labs. I will talk about algorithms here, but in the labs they will talk about more on implementation and C of that. So it will be very useful for you to relate both of them. We both of us will be in sync to teach you that. So please attend the lab sessions, all of you, from next week whenever lab sessions are scheduled. And also make sure that you practice. Even if you don't have the lab access enabled, C compiler is not something very difficult to get. Many online C compilers are also there. So you can initiate that, use that for the temporary. In the meantime, if the lab team gets delayed to get you access or anything, also you can use the online version or your own C compiler and work on it. But practice, especially in lab sessions, practice along with the faculty so you can understand it. Okay, very well. And this data structures course is very vital, important, because it is going to be prerequisite for many other courses you are going to learn in this program as well as elsewhere. You want to do higher studies, you want to do a master's in computer science, or you want to learn AI, ML, machine learning. I can see many of you are interested in artificial intelligence, machine learning. So data structures and algorithms is a first primary prerequisite along with math, linear algebra. If you look at what are the prerequisites for AI, ML and all, linear algebra. In maths, it is linear algebra, probability, statistics, etc. But in computer science, it is more important. You have to understand computer organization, operating system, along with data structures. If you look at our MTech data science program, in the very first semester, we have a course data structures and algorithm design, because we want all the MTech students to study data science. Before that, we want all of them to be very thorough in data structures. Then only they can go and do data science activities. So it's a very important course. It's a mandatory course everywhere in any program you take. So please put your lot of attention. It is not just for grade in this course alone, but it is for much more holistic understanding of many other concepts in computer science. This courses will be very useful. And you will apply a lot of things you have learned in computer programming in this course. If we have taken it, we have taken the concept of C. That is, we have taken programming language as C only. We have other programming languages, and we have mentioned about say, for example, Python we can use, JavaScript we can use, Java we can use. But why are we going with C is the underlying memory allocation plus how the data structures are managed in deep can be understood very well when you program a data structure in C. So that understanding is what we want rather than the output. Anyone can implement a stack data structure, and nowadays with ready-made libraries, if you go to Python or if you go to any other modern languages, you have ready-built libraries available to do data structures. We don't have to, and no one writes sorting algorithm today. You have a sort function which can sort you. If Excel has a sort function, right? We just don't write sorting algorithm there. Excel has a sorting function and it is available for use. And even if you ask ChatGPT, it will give me many sorting algorithms which I can readily use, right? But why are we asking you to do it in C? You will not only understand the logic behind the algorithm, you will also understand how the data structure, the memory allocation happens. How do you access the backend memory? That is how you means how the system, computer system accesses the backend memory. All that information is highly required for you to have a deeper understanding of the concept. Okay, so there is a purpose why we want C. We don't, many of you have a, so first question, many of them ask when I say C is the programming language, they kind of say that we are not learning new languages. We want to learn Python or we want to learn something on React, JavaScript, all those things. Yes, of course, you can learn all these languages, but there is a purpose why C is the programming language we are using, especially in this data structures course. It has a reason. It has a it gives you good understanding. When you learn about primitive data structures, you will be using those pointers. You can directly interact with the memory allocations at the back end. So this will help you to have a good understanding of how the entire thing works rather than just simply using a ready-made function to sort and get the output. Okay, so when it comes to learning, it is not about using ready-made solutions. In work, it is obviously using ready-made solutions. But in learning, you have to understand what is behind the scenes of that working. Okay, so you should not be, when you are learning programming courses and data structures, you should not be the person who's using the sort function. You should be a person who's creating sorting packages and libraries and giving to anyone else. So that is what we want out of you, and not someone who just uses ChatGPT on. We want you to build AI agents or LLM agents out of the LLMs which are available. We don't want you to be end users or non-technical users who want to get something implemented and available. Okay, so that is the idea. So don't get diversed or don't get distracted by many other factors which are influencing. Of course, you have in modern world, you have options to replace coding, you have options to replace development, etc. But fundamentals is something we have to learn. There is no shortcut to that. Okay, same analogy. So if you look at many of the professors or many leaders in your industry also will agree to this. We have calculators, but none of us stopped from learning how to do basic arithmetic operations, right? So we learned it because though we have calculators, we don't do additions by hand or by mind today. We use calculators, but we know on the back end how it is working. So if you don't know how it is working and just using it as an end device, you know what are the shortcomings you will face when you are actually using it. You can be a more intelligent and an expert user of a device or a product when you know how it is working in the background or behind the scenes. So that is what we try to achieve by all these courses. So ensure you kind of put in your efforts, right? Let me start with this today's session, which is on arrays. Now, why do we need to study data structures? What is data structuring, first of all? So now any data we have, right? For example, student, all of you are students in this particular class. So we have around 80 plus students. Each of you have a name, each of you have an ID, which is unique. So how do I store this data? What all information will be available? What kind of data do we have? And what kind of information we need to perform on the data? What kind of operations we need to perform on the data? For what will I do with the student database? I collect all the students everywhere when you are admitted. I collect all the student details from your date of birth to address to name to your educational qualification, everything we collect. But what do we do with that data? There is so much of data, right? 80 plus data. So say I'm as a faculty, do I need access to all the data or what kind of data I need? I need only data where I know the student ID, I know the student name and what course they have enrolled. But as a faculty, I need only that details. I also need details. What are the previous courses you have learned so that I can curate my content accordingly. I don't need anything, any other details about your house address or your phone number. I need your email address, of course, to contact or make you part of an LMS, but I don't need your personal contact information. I don't need what is your native town, or I don't need any other 12th, what is your 12th percentage. I don't have access to all these information, right? So data is there, but how do you organize the data or how do you put that data to use depends on what I want to perform, what kind of operations I want to perform. Consider the same example. You have a student database. Okay, all the data is there. Now I want to create a small, I want to search and select the top rank student in a particular course and I want to give some prices. Okay, so if I want to develop a system to do that, what is the operation I have to do on the data? Okay, before going into the operation, okay, I told you about the student database. To select the top ranked student and give price, what are the data I need about the student? Tell me what all data I will need about the student which is stored in the student database. Do I need all the data stored in the student database to select the top ranked student? Yes or no? Come on, let's make the class interactive, otherwise it will be boring. Tell me. I'm not asking any technical tough questions, simple questions only. So in a student database, We have student name, ID, date of birth, house or personal address, father's name, mother's name, phone number, and then the courses the student have registered, the marks the student has secured in that course, etc. So if I want to create an application to select the search for the top ranker in that course and give a prize, what all data I would need from the student?
Student name, his marks.
Okay, student name and his marks. Of course, along with name, you need ID also because name is something not very unique in India, right? So we need student ID, which is unique, right? Student, there can be two Gokuls also. So we might not be able to differentiate with Gokul. So ID is unique and formatted. So we can use ID, student name, mark. Apart from that, do you need a house address? Do you need a personal phone number? No. So it is only to select the top, you need only certain data. So what kind of data we have and what kind of data we need for our application is the understanding we should have. So structuring data is not just I get the data, it's not like you will get questions like insert into an array, delete into an array. No, you should know how to apply it in a scenario. Why, first of all, I should choose an array? Why should I go for a stack here? That is the understanding you should have, right? Then only comes the operation. So now Gokul said, do all of you agree? I hope all of you agree. We have to have student name, student ID, and then a mark. Okay. Now, what will I say? I put all this in the data. I have the data. Now, what kind of operation I have to perform on the data to get the top rank student? What I have to do? I have, let's say I have the student ID. Okay. Then I have the student name. Then I have the mark. Say, let's take data structures course only. I have the marks of all the course, all the students of this data structures course. So to identify the top ranked student, what operation I have to do on this data?
We need to compare the marks of all the students.
Okay, you need to compare the marks of the students and what will you get? What will you get when you compare?
We will get the highest mark.
Okay.
After that, we need to get the name and ID of that highest mark.
Okay. So first you have to do a operation on the mark column, right? You have to get the highest mark. So you have proposed one option where you compare, like similar to the maximum number example we did in the last session. You compare one number to one number, and when you get the mark, you do it, right? So you then you see which student has that mark and you select the student. Very good. So that is one operation. Are there any other approaches we can do? This is exactly right approach. So what kind of operations we do? First, we search for that highest mark. We find the maximum element. And then for that maximum element, we search who's the student ID and student name, right? So what are the other, do you think of any other options we have to do? Any other method we can find the highest mark? Okay, let me, if I want to give first three prices. So first I said I want to give only one prize. So you gave me the mark. Now I ask you to give me the first three prices. What will you do?
I'll compare all the marks and get the highest mark. After that, I'll compare all the marks excluding that highest mark. After that, excluding two highest marks, and then I'll order 1, 2, 3.
Okay. So why do you think your solution which you have given is the right solution? It will give you the output, but isn't it complex? Practically, if you want to implement in coding, isn't it complex to compare, remove the highest mark? What is a much easier solution? Think about the data. What is there in marks? Just numbers, right? So how can you fetch the highest or the largest three numbers easily? Any idea, anyone? Okay, let me put it this way. I give you the data in an Excel file and ask you to retrieve the top three numbers. What will you do? Sorry?
We try to arrange descending or ascending order.
Yeah, you
Correct.
try to ascending order or descending order and you get the large three numbers, right? Basically what you're doing, you're trying to sort the data. Okay.
Yes.
So if you just want to get one largest mark, the operation we can do is like search or find the maximum element. But we are going to have repeated operations, like get the first mark, then get the second mark, or get the average, or get the mean, median. So if I'm going to have some repeated operations on the mark, isn't it better if I have store the data in a sorted fashion?
Yes, it will be
Yes,
helpful.
If I save it in a sorted fashion, you don't have to perform repeatedly, right? You can easily find out the largest mark, second largest mark, third largest mark, or you can, if I want to ask for the median, you can give me, right? So that is where what kind of operations we need to perform on the data will depend on how the data structure will be structured, or how the structuring of the data will happen, and how we will do the operation. This is basically, I can still, whatever the first solution you gave is the right solution. But why I'm going for the sorting option, second option, to maximize the efficiency. I want to do it in a better way. I want to run it in less time complexity, less space complexity. Okay. So you can see what is the relation between each of them. No, first of all, I don't have to use all the data. I have to have an understanding of what kind of data we have and what are the only data I need to perform operation on to get the result. So my objective here is to fetch the largest student. So first of all, I should have an understanding of what the data is. That is the first point. And what all operations I have to perform on the data, that understanding is required, because without that understanding, I cannot decide which data structure to use or what kind of method to use, etc. So I need to know what is the objective, what kind of operations do we have to perform to fetch the result. Now with this are the answers to these questions will influence the choice, that is which data structure will be chosen. Now you know we need a sorted data. Now we know we have three columns. Now what to choose, whether an array or a heap or a stack, that you have to choose. How will you choose that? Only if you know how an array works, how it stores data, what is the time complexity of insertion, deletion, searching in an array. So you will see which array is best in this case, or you will then choose stack, whether stack will be best in this case. I'm going to do a sorting. So linear search is not required. If I have a sorted array, I can do a binary search to find an element. So I should know this understanding to choose the appropriate data structure. So this is what we are going to learn in this entire course, what to choose, how to choose the appropriate data structure for the given problem. Why do we have to use an array? Why do we have to use a stack? What is the benefit we getting by using a stack? All this will be the reason why are we doing this. I can do the same thing in an array. I can do the same thing in a queue. I can do the same thing in a stack. But why are we taking the decision of choosing the appropriate data structure to maximize the efficiency, reduce the time taken, reduce the space taken, get a better algorithm? That is the idea. So all of you understood why are we need to learn different types of data structures, why data has to be there. Now, why this choosing the appropriate data structures is very important. Why? Because all data structures don't give you the same time complexity. Okay, so in an array, if you do a linear search, it takes order of n. What does order of big O of n means? We learned in the last class. What does big O of n means? Do you remember?
Upper bound.
Upper bound. Big O. Big O is upper bound. So it takes n amount of time. N is the input size. So to execute a linear search, you have to traverse through all the n elements. Then only you will find out the element. So that is why it is big O of n, the upper bound of n. So maximum it will take order of n time. So if there are 10 elements, it will take order of n or order of 10. So that is how it is. Same, if I have a sorted array, I can do the search in a n log n, log n time. Okay, in a binary search. I will tell you how it is log n, etc. But generally, n is less than log n. So you know what is the value of log n, right? All of you know logarithmic? Yes? Log n to the base 2. Okay. So log n to the base 2 is less than n or greater than n? Log n to the base 2 is less than n or greater than n? Come on. It is less than, right? Logarithmic values are less than. So if you look at time complex, I will come to that time complexity thing, but we should know this, then only we can choose the appropriate data structure, and that is what we are going to study. So we have an example, the same student example, similar to that. I am giving you one more example here. Say we have an electoral database, the elections database. It's a very huge database. We have it for the entire country, means it has to hold so much of information. So if you want to search the data to find people in a separate, in a particular town, right? Would you need a sorted data or unsorted data?
Sorted data.
Okay, on what you will sort it? On what parameter or what field you will sort it?
By the person name, initial name, or house number.
Maybe you will have A, B, C. Names is fine. House number, is it incremental? I don't know. I'm not sure because
But, yeah, yes, ma'am. And it is also unique, right? We can find it. We can sort it.
Which one? House number.
House number.
House number is not unique, no? Every street will start from 1.
Yes, yes.
And some will have 22, 22A, 22B, and 22A bar for 47, which will be the old number. So house number is not very, very streamlined in our country, right?
Yeah. Yes.
So what will you sort? Any other, can you think of anything? This is just a very random question. It is just a brainstorming of ideas. We might not have a right answer or a wrong answer.
Yes. By phone number also we can find, I think.
Phone number will be unique. So that is one good thing, right?
Yes.
The Aadhaar ID
Electrical.
card.
Yes. Electrical bill number.
Something like that we can find out, right? So these are some things we can look at it, sorted or unsorted, right? So now, same example. So you have a hospital waiting line, you have patients, right? So in that, if you want to call one by one to visit the doctor, what kind of a data structure you will use? Whether you will use a data structure which follows last in, first out, or first in, first out.
First in, first out.
First in, first out. What will happen as a problem if I do a last in, first out?
I mean, those who come at first, it might be delayed.
Right. So here the most appropriate option is first in, first out, and not last in, first out, right? So all this, for a given situation, you select the right data, you select the right data structure, you put it in the right structure, you capture the essential data required. So you don't take the entire student database, or you don't take the entire electoral database to calculate the number of votes. You just need some basic data alone to calculate the number of votes, or you need some basic data to calculate the top student. So you choose the data and you choose what data structure, whether I want to go with a stack or a stack with last in, first out, or a queue with first in, first out, or an array with the data. So I decide based on my understanding. So that is what is called as data modeling. So what is data structure? It is a way where we are organizing our data, right? Which allows the programmer to easily access or modify the values within them. So data structure organizes data, but why do we need to organize data? It is already there somewhere. Why don't you use it as it is? Without converting or organizing it into a structure, your algorithm efficiency will be very high. So you have to put it in a structure to organize it. So that is why you can get more efficient programs which runs in less amount of time, right? So let me give you a very classical example. So how many of you are aware of stack? At least by the name, not in terms of operation, the word stack or a stack data structure. Have you heard of this name anywhere before?
Yes, ma'am. In data structures, it is one of the data structure.
Okay, what is the good? What is the main use of it, or what is the main working of it? Stack is a last in, first out option, right?
Yes, ma'am.
Any example where it is used in real life? Can you tell me any application, any product where stack is used? No? Okay, I will tell you example. How many of you have you do undo and redo, right? In Word, in PPT, anywhere, undo and redo operations, right? So that is
Yes,
where
yes.
stack is used. Why do you need a stack is last in, first out. Okay. So so the last action which I did will be on the top and then will be the other actions. So when I undo, I undo the first action. Then again, if I undo, I do the second action. So this way stack is more efficient. What if I put in undo operation? Say I don't use a stack and I use an array, what will happen? Or a queue. I put first undo operation here, second undo operation here, third undo operation here, fourth undo operation here, right? So all these operations, they are indications of that we have to fetch it in a right way. Okay? So this undo operation, we have to always get the latest one. And once that is done, we have to get the previous one. So if I put it in an array, it is going to be very difficult for me to get the latest one because I need to know the length of the array. I need to look at the indexes. Then I have to traverse through that and then get it. So if I don't choose the right data structure, I can still have a working solution, but it is not going to be the solution. It is not going to be an efficient solution. It might turn a program which is running in milliseconds or microseconds to a program which is running in seconds or minutes, right? So the choice of the data structure is going to make the difference between a program which is running in few seconds or many days. So the solution we always think of should be efficient. It solves the program with lesser time complexity and with the lesser space complexity. So that should be always our goal. So in order to do that, choose the right. So first of all, we should know what stack operations can be better, what array operations can be better, etc. Then only we can choose the best one. Okay. So we have to do that. So let me give you an example. Okay. So swapping of two numbers, all of you would have done this in C programming, right? Swapping numbers.
Yes,
sir.
we
Yeah.
did.
Yeah.
Yes, sir.
So here we have one method, swapping number, where we use the same variables, two numbers A and B I want to swap. So I use A plus B is equal to 50, right? And I assign it in A. Then for B, I make it A minus B. And again, A, I say A minus B. So this way I have swapped the two numbers. So this is method 1. In method 2, I use a temporary variable. I assign the A value here, then replace it with the B value in A, then B, I replace it with the value. So both the methods are correct methods, right? But if you look at the time complexity, right? How will you calculate the time complexity? Number of operations. Remember, how did we calculate? Number of operations. So how much time this line will take, first line? Reading from memory, one arithmetic operation.
Assigning.
Assigning.
4.
Okay, 1, 2, 3, 4. Okay, 4 units of time. What about this statement?
Same 4, ma'am.
Same.
Okay. So something like this. What about this one? It's only assignment, right? 1 unit. This is also assignment. This is also assignment. So time wise, this looks simpler because you are only doing assignment. You are not doing any arithmetic operation. For arithmetic operation, to do that, you need the arithmetic logic unit, etc. Right? But compare space. It is only using 2 variables. Here it is using 3 variables. Additionally, 1 space you are using. So there is a trade-off between whether you want to go with less time or less space. Okay. So generally space is considered more costly. So time, it is this 1 and 4 doesn't make very big difference in the swapping because it takes the less amount of time only. Because in terms of space, you get a new memory allocated, then you have to remove that memory, temporary memory, reallocate it. So all that takes more practically more amount of time. So method 1 is already always preferred practically, but you can understand that 2 dimensions we are looking at. One is time and another is space. So the number of operations depends on the time and it increases the CPU, the processing unit's time. Then we have the number of variables, which is the space, which increases space, and it says that it is the memory, right? So CPU is based on the number of operations, time complexity, and the number of variables, the space we use is depending on the memory. So these are the 2 aspects we always look at when we want to choose the right data structure. Okay. Shall we take a small break here? Come back. Yes, 10 minutes break we will take. Okay.
Okay, ma'am.
And we will come back and start with arrays, our first data structure.
Okay, ma'am.
Okay, so let's continue. Okay, selecting a data structure. So first we have to know what are the operations that must be available or supported in that data structure. Then only we can select the data structure for our problem statement. So whichever data structure meets our requirements, the best meets our requirements, we will. So when I say basic operation, so if I want to read from an array, for example, let's go back to our example student database only. So if I want to find out the top mark, I have to read through all the array elements, right? So I have to read the marks. So access is one thing. How do I access the array? Second is if I want to find out a mark of one student, or if I want to see whether a student has passed or failed, then I have to search for that student. So search is one operation. Then if I want to insert new data, insert new students or delete students, then it is like delete operation. So these are the basic operations we will perform in any data structure. Access it, retrieve data from it, insert it to it, delete to it, and search in it. So these are the 4 basic operations we will perform in any kind of a in any kind of data structure. Okay, so we will look at how this is possible in each of this. So today we are going to start with array. So this I told you in the last session itself. Array, what is good about array? It is continuous memory location. So if you have the starting point, you can easily access all the data types in an array. So array is a collection of homogeneous data items. It is stored in continuous memory location. Okay, so this homogeneous data items means all the items are integers or all the items are basically characters. That is how it is. So this I'm just kind of informing you that this is not the same in many programming languages. Okay, for example, in JavaScript, in array, if I say int array of 10, it means that it is an integer array. All the data is a homogeneous data items. All of them are integer only. But in some data structures in JavaScript or in other places, the implementation and array can hold multiple data types also. Okay, so this is for your information. Don't get confused. But array is mostly for storing homogeneous data items in continuous memory location only. Okay, now comes the next aspect. So why it is 200, 204, 208? Anyone can tell me? We discussed this in the previous session also. Why plus floor we are incrementing? Any idea why are we incrementing plus 4 here in a data structure?
I think it takes byte size 4.
4 is the integer byte size, that is we are assuming here. Okay, so what is the byte size? Every programming language, depending on the operating system, every data type will have a fixed number of bytes. So integers usually in a 16-bit or a 32-bit system, it takes 4 bytes. It is that minus to 16, the length is like from this integer to minus plus integer, you have this number. So maximum 4 bytes it takes for every integer to store. So the maximum length of the integer is available. So now this is 4 bytes in one operating system. It can be 2 bytes in other places also. It depends on where you are executing the program. So depending on that, that amount of memory will be allocated. So integer is generally 4 or 2. So if it's a 4, it is 204, 208. That is why it is, but it will be continuous. If it is 2, it will be 200, 202, 204 like that. But it will be continuous. We will not store something in 200 and then store something in 210 or 250, etc. That is the idea. It will be continuous. The next elements can be accessed in a continuous fashion. So that is very important in the array data structure. Next is why we need an array. When we want to store multiple marks of a student of the same data type, this I discussed in the previous session, so I'm skipping this. We need this because it has to be, we cannot store them as individual variables. It has to be stored as a complete array only. Okay, so that is why we are maintaining this. Sorry, there has been continuous call which is coming. I'm really sorry. Okay. So now what is the benefit of the array? You have multiple, instead of working with many variables, you store it in a single array, which all the way, and you can easily access them. So since this I discussed in the previous class, these two slides, I'm skipping them. So now let's go to the declaration of creating an array. So how will you create an array? All of you familiar with this statement, first statement? What type of an array is this?
Integer.
Integer array
Integer
with
array. How
size
many
of 4.
elements? What is the size?
4.
4, right. Now, what is the second line? Have you seen this line anywhere before? In C programming, when you learned?
In linked list.
You learned linked list before?
Yes, ma'am.
Where? In computer programming or personally?
Previous semester.
Okay, in computer programming you learned.
Yes, ma'am. Yeah.
Okay. So what does this line do? What is the difference between this first line and the second line? What will malloc do? Think.
Ma'am, will it allocates memory?
Okay, that is right. That's exactly right. It allocates memory. So when you can create, what happens in the first line, what happens in the second line?
Ma'am, in first line, we are assigning the how much value to the array. And in second line, we are allocating the memory to that array. I think so.
No, that's not right. Both are statements to create an array only. Okay, let me tell you. So this also we are creating an array. This also we are creating array. Total bytes, I can mention exactly the number of bytes, or I can put here size into, number of elements. Say 5 is my number of element into size of int. Okay, size of int is a function which will give the size of integer in that particular operating system or the system they are executing. So if it is 2, then 10 bytes will be allocated. If it's 4, then 20 bytes will be allocated. So the first method we are having is a fixed size static array which is getting created at compile time. Okay, the second method is allocating memory dynamically at runtime using malloc. The choice, why have we two methods? Depends on the programming basics, programming requirements we have, particularly flexibility in array size, the memory management, etc. So since you haven't studied about COA, the computer organization, you would have had some idea about digital design also. You're starting right away. So I will tell you how the program memory is located. Okay. So the arrays are typically allocated in the stack part. Okay. Inside the stack part, stack is a memory. Okay. Whenever, so stack is a memory which is managed by the compiler. So when you use the first method, the array is created in a compile time. So the array will be created in this region, in the stack region. But when an array is being dynamically have to be created on the runtime, it is managed more by the programmer. So it is created in the heap region, okay, which is managed by the programmer. So there are 4 areas of memory: stack area, heap area, then data area, code area. Okay, so when I say stack area, it is used by the program in execution. So our C program which is running means that is the program is execution. So main call function, then we'll have, I think there is some data hidden here. There is some misalignment. Okay, so the stack area is where we store our local variables, manage state functions, all that. So memory is automatically managed by the compiler who's executing it. So this is stack memory. Then there is heap memory, which is used by the programmers. Programmers can allocate some bytes of memory in that. You can typically allocate and deallocate memory. So the programming language will provide you functions to do that. So in C, we have malloc, which can help you to allocate data in a memory in heap, and new in C++. Similarly, for removing free and delete in C++. So this memory allocation options are possible in the heap area by the programmer. That is, we can write programs. So in this, we are saying dynamically during runtime, allocate 5 bytes or 10 bytes of memory to store an integer. So that is what we are saying in this. Okay, so this is one method, heap area, stack area. And then we have the code area where the running programs code is stored. And then we have the data area where the program's global variables and static variables are stored. So this array, if it is created as a global variable, not inside any function, it will be stored in this area, in this data area. Whereas if it is created inside any function, if it is a local variable, it will be stored inside the stack memory. Okay, so now you understood the difference, how to, the same array only we are creating, but we have different ways to create an array. Any doubts in this before I move forward? No doubts? Okay. I assume all got the understanding of it, right?
Yes, ma'am.
Okay. So now how do you access the array? Same, whether it is created using malloc or whether it is using created dynamic array or static array, accessing is same. You have to just loop through the array, num of x, and you can access the array. So there is no change in that. Okay. Now let's look at the time complexity. So I have an array. Okay. Now if I want to read through the array, right? I want to read, say I have a, let's put this array as name A. If I want to read A of 1, or if I want to read A of n, or if I want to read A of 5, it just takes me 1 unit of time because I can just directly access it, right? And since array has continuous memory location, I don't have to traverse from the first node to the second node or third node, because I know if this is 200, it will all, the second one will be in 202 or 204, 208. So I know that. So reading any element of an array, it is only 1 unit of time, right? What about insert? Why it is order of n? Can anyone explain? Why insert is order of n? What
I think,
happens if I, yeah,
ma'am, I think we'll insert the element in the nth place.
right. So we will insert an element in the nth place. A new element is added, right? So if you want to increase this, insert takes a longer option. You have to traverse through the entire array and take. Another problem is also there here. Okay, if you have declared an int array of 4, you cannot add 5th element. So you have to grow the array. I will talk about growing the array, growing complexity of the array also. But as you leave the size, you have an array of 10 size, but you have only 5 elements and you want to insert the 6th element. You have to traverse through the array. So first A of 1 plus A of 2, you have to incrementally and then go to A of the last element and then insert the array. So that is why it is order of n. Similarly, why delete also? Delete also you have to traverse, search through the element, right, and delete, or if it's normal delete, it will be deleting the last one. So that is also will take time. Search also, n, we are not talking about binary search here. I will talk about binary linear search next. So we have to search one element by one element. So that is linear search. So it takes order of n. Okay. So array data type is provided by most programming languages. It can be selected by one or more indices. Okay. What is the dimension of an array? Is the number of indexes needed to select an element, right? So if you store words in an array, is a single dimension array sufficient? If I store marks, we know that single dimension is sufficient. So if marks are not sufficient, marks is not required, what will happen? If you want to store something like word or something more additional, how many dimensions will you require? Can I store it in single dimension? Say I want to store my name. Okay. So this is a character. So I will have only one character. So if I put CHAR of 4, it will have only one character. But if I want to store 5 students' name, then I have to have another dimension, right? Yes or no? How do you store strings in C? How do you store strings in C? Have you remember? Recollect? Character array is what we use, right? When you want to define a sequence of characters, right?
Yes, ma'am.
Yeah. So this character array, if it has to be, we have to do it sequentially. So the words or other, when you have a long sentences, etc., you have to make it a, you have to ensure that it is the required dimensions are increased. Okay. So depending on your program requirement, it can be a single dimensional character array or multi-dimensional character, 2-dimensional, 3 dimensions, etc. But right now, let's focus only on single dimensions only. So the basic operation is to traverse through all the array, print all the elements. Then you have insertion, add an element. Then you have deletion, which deletes at a given index. Update at an element at a given index, then search. Now let's look at traverse. You have an array, integer array. Initially, I is initialized to 0. The maximum is 10. The number of elements. We have only 6 elements, but it is 10. The array size is 10. Okay, so we go through the array and do a print of the array. Okay, so this is simple traversal. Any doubts in the traversal? I think I don't have to explain this percentage D and all. All of you are familiar with C language, right?
Yes, ma'am, we do.
Okay.
Yeah, ma'am.
Okay, fine. Now coming to the insert operation, to insert one or more data elements in the array, a new element can be inserted at the beginning, at the end, or any given index. There are 3 options we have. So how do we do that? So if I want to insert at the beginning, what is the problem? It will replace, right? So let me take an example. Say I have 5, 1, 7. So now if I have my arrays, so if I have to insert at A of, say this is 0, 1, 2, 3, 4. So if I have to add a new element at the end, right? I can just add A of 4 is equal to 10. Okay, it's simple. But if I want to add a new element at the beginning, what I have to do? I have to move all of these elements one step further. And then I have to insert 10 here, which is a costlier operation. Then if I have to add an element at a given index of an array, say A of 4 is empty, then it is fine. But I should know the end is A of 4, so that I have to traverse first of all. So if I want to insert at A of, say, A of 8, since we are declaring a 10 array, it is empty. So I can say A of 8 is equal to 15 directly. But in between some elements which are there. So 10 is what I have declared, array size. Okay, if I say 10, I have declared. So then at 8, I will insert this 15, but there will be some elements in between which is empty. Or if I do A of 2 is equal to say 10, it will replace this value with 10, update it with 10. So each insert operation, generally it might, if it's just, if you know the index and you want to update, it is just order of 1. But if you don't know the index, you want to insert at the end, it will take order of n. And if you want to insert in the beginning, you have to replace every, you have to shift every array, then also it will take order of n times. Okay, so this is about insert operation. Similarly with delete operation also. Removing, first of all, you have to know which element you have to refer. So you have to search for it, right? So you want to say if you're removing an element in between, okay? So you have 10, you have 5, 2, 4, 6, etc. So if I want to delete 2, I have to remove this, and I want to replace this as 4, replace this as 6, and reduce the array size by 1. So that is the logic we have in this delete operation, where we are saying you start, say j is equal to k, you start, let's so this is j, this is k. We say I have 5, 6, 8, 7, 9. Okay. Now repeat steps 4 and 5 while j is less than n. Okay. So we write a of j is equal to a of j plus 1. So we remove 6, we write. Okay. Then we make j, increment j. So j becomes here and k becomes k. N is equal to n minus 1. Okay. So first we have to repeat these steps until j is less than n. Okay. So now again we will replace this by 8. Then move j here. Then we will replace this by 7. Then move j here. Then we replace this by 9 and we move j here. Okay. So now this becomes n equal to n in this step. So we stop here, right? And then we set n is equal to n minus 1. So the array size is reduced. So we have it here. So this is how we delete the last element in an array. Okay. So we have to reduce the array size and organize all the elements in the array. Update operation refers to updating an existing element, which is very simple. So if you know the index, it is order of n. That's all. Any doubt in insert, delete, or access operations? Shall I go move to searching?
Yes, ma'am.
Okay, fine. So in searching, we have two types of search. Okay. Linear search and binary search. Linear search is more array based. Binary search is a little, we would include a tree kind of an approach, etc. But let me explain both the searches in an array. In a linear search, you have an array. Okay. So let's say this is our array. For each item in the array, one item by one item, we put it value. Item is equal to, we check whether the value, say I want to search for the 3. Okay. So let's say I have an array 2, 3, 4, 5. Okay. Now for each item in the array, I take this as I compare this element which I want to search with the element. So for 9 and 3, I compare. If it is equal, then I will return a of 0. If it is not equal, I will go to the next element. So a of 1 and a 3 I will compare. It is not equal. So if it is equal, I will return the index. If it is not equal, I go to the next one. So a of 3 it is equal. So a of 2 is the location where the search element is present. So this value is present in a of 2. So you return the item's location. Okay, this you can stop at this place, end if and end for, or sometimes if you want to look at duplicate values, say there will be all the instances of 3 if you want to record, then you will continue till the end of the array. So if you want to search for multiple values in an array, you have to keep repeating it for all the end of the array. If you want to, if it's only unique occurrence or distinct occurrence, you don't have to repeat it. So this is a linear search program, right? So you search how, first of all, you check how many elements are there. You get the input of the array elements. Then you ask for the element to be searched from the user. Then you check if a of I is equal to x. If it is yes, then you break and you return. If it is equal, then you return and you come out of this for loop. And if I is less than n, you print element is found at index I. Okay. Now, if it is not equal, then you repeat the array till the end of the array, and you will break when the loop ends. So if the I is not less than n, it means the element is not found in the array and you come out of it. So this is linear search. So what is the time complexity for this approach? So let's do time complexity for each item in the array. So how many times the loop will run? N times, right? And this is one operation. This is also return 1. So n times f of n is equal to 3n. Okay, when f of n is 3n, what is g of n? G of n is also, you take the upper order term, right? Sorry, it is not 3n, n plus 3n, sorry. It is n plus 3, right? N plus 3 or 3n? Sorry, I missed. I made a mistake. So the loop will run n times. Each of these statements will run one time, right? So it is 3n only, right? So now, how will you calculate the big O when f of n is 3n? You take the highest term, ignore the constants. That's what is the law for big N. So it is order of n. So the linear search algorithm is, the time complexity is order of n. Now, what is special in binary search, right? So in binary search, what we do, we get a sorted input. Okay. So we take a sorted input, that's mandatory. Okay. We take a sorted input. Okay. So now if I want to search, say, let's say I want to search 18. Okay. I don't go one by one in binary search. I find out the middle value of the array. Okay. So mid element is beginning plus end by 2. Okay. So here beginning is, say, let's say 0. So 0 plus 7 by 2. 7 is 3. 7 by 2 is 3.5. We'll take the upper seal. So mid value is 4. Okay, mid value is 4. So we always take the seal value. Okay, mid value is 4. So now A of mid, what is, first we compare 18 with A of mid. So what is A of mid here? What is mid, first of all? A of 4. Right? Mid is equal to A of 4. What is A of 4?
13.
13. So we compare 13 and 18. If the mid value is equal to the search element, we have found the element, we return the position. So if mid value is equal to the search element, we found it. So position is returned and we directly end it. Okay. Now, if mid value is greater than the search value, then we have to search only this part of an array. Because the array is sorted, if our value, whatever we are searching, is less than the middle value, then the element will only be found on the left side of the mid element. If the element we are searching is greater than the mid value, then the element will be only found on the right side of the mid element. Why are we giving this rules? Because the array is sorted. If the mid value is 13, the element we are searching is 18, it will always be on the right side of the 13, right? Yes or no? Do you get that?
Yes, ma'am.
Yeah. So
Yeah.
always it will be on the right side only. It will never be on the left side. So when it's never going to be on the left side, there is no need to search on the left side at all. Right. So what you will do, you will compare the mid value and the search value. So if 13 is greater than 18, then we will search only the left side. If the mid value is greater than value, we will search only the left side. So that is from 0 to 3. So if this is true, we will search only from 0 to 3. Or if this is false, right, we will search from 5 to 7. So this way we are reducing the number of elements we have to search. So this reduces the time complexity. In a binary search, this is what happens. So now let's go back to this. So A of 4 is 13. So 13 is less than 18, which means it matches the second if. So begin value is set to mid plus 1. What is mid value? What is mid value now? 4, right?
Right.
4.
Beginning, yes.
Mid value is 4. So begin is mid value plus 1, which is 5. So we start the search from 5th element, then repeat these steps 3, 4. So while we repeat, how long we will repeat until it is less than end. So end is the upper bound, which is 7. So end is upper bound. Begin initially it was 0, right? Now begin has become 5. So our array has been reduced to 5 to 7. So we repeat this step. Now we again say mid. Mid is equal to begin plus end by 2. So what is begin now? 5. What is end? What is end? 7 by 2. Which means what is mid value? 6. Right? So mid value is 6. So A of 6. What is A of 6? 18. So we compare 18 and our search value. If it is equal, okay, we have found the element, proceed. What if our search value is 19 instead of 18? So again, it will not find, so 18 and 19 will be compared, 18 greater than 19. If 18 is greater than 19, you will search only 5, this part of the array. If it is greater, it is a recursive algorithm. You repeat the step. So first you search for 7 elements. Then you found out it is only will be on the right side. Then you took only 4 elements. Now within that 4 elements, you will either take right side or left side. So you keep dividing the array into smaller parts. Okay. So that is how you do a binary search. Do you want me to do one more example? Let's do, because it gives more clarity. Okay, now I want you to give me the numbers. Can you give me the sorting numbers? One of you, any one of you?
2.
Okay.
2, 4, 6, 8, 12, 16.
14 or 15.
14. Yeah, 16.
What is the search element you want to search?
8.
It will come in the first step only. Give me some elements, edge cases. Shall we take 2 this time?
Yes.
Okay, let's take 2, then we will do some other element also. Okay, so first, what is the begin value? Tell me. End
value.
What is the end value?
7. 6.
6. Okay, we can have 1 to 7 also. That is also okay, but we are just taking 0. Okay. Now, what is begin is less than end? Yes. So what will be mid now? This is the first iteration. Okay, in first iteration, what is the mid value? Begin plus end by 2. 0 plus 6 by 2 is 3. Mid is 3. So what is A of 3?
8.
8. So 8 is greater than 2? Yes or no? Yes.
Yes.
So this condition. So end becomes mid minus 1. What is mid? 3. So 2. End becomes 2. So this 6 becomes 2. So begin is 0, end is 2. So we have to search only this part of the array. So we repeat the steps 3 and 4. Now again we go. This is the second iteration. Again we set mid. What is mid value now? Begin plus end by 2. What is begin? 0. End is 2 by 2. So what is mid value? 1. 0 plus 2 by 2 is 1, right?
Yes, ma'am.
Okay. So now what is A of 1?
4.
4. Okay. A of 1 is 4. So now 4 greater than 2, true? Yes. So which means this again, this value is, so end will become what now? Mid minus 1. End will become now 0.
0.
Yeah. So now
Yes.
again we repeat the steps. Can I repeat the steps again? Begin is less than or equal to end. So now begin and end is same only. Right, this has become 0, so it is still equal, so I can still repeat 3, 4 steps, right? So now the third iteration, I'm doing the third iteration. Now what will be mid value? Begin is 0, end is also 0, divide by 2. So mid is 0.
0.
Okay, now what is A of 0? A of mid?
2.
2. So now 2 is equal to, so if it is equal to 2, we return the position, which is the mid value. So the element we are searching for is found in 0th index position. We complete that and go to step 6 and exit. We have found the element. Now, what is the difference between linear search and binary searches? If an element is found in the last position or somewhere in between, you have to maximum search n times. That is the worst case. But here, the search option you are dividing by 2. We have never traversed this side at all in this example. So if I want to search something here, I don't have to traverse on the last, the other side at all. So we are always reducing the, so if you look, the first time begin was 0, then it was 6. So 6 elements we were searching. In the second iteration, begin was 0 and it was 2. So only 3 elements I'm searching. In the third iteration, begin was 0, end was 0, which means I'm searching only 1 element. So every time the array size has been reduced. So first time it was 6, second time it was 3, second time it was 0. So you can see it is reducing by half almost every time. So that is where the binary search is more beneficial in terms of time complexity. So this you have seen an iterative version of the binary search. You can also write binary search in recursively. So all of you know what is a recursive function?
Yes, ma'am.
So what is a recursive function? It calls itself, right? The function which calls itself until there is a edge case, right? So here the recursive function is, this is a start point. Until low is greater than high, you can solve it, right? So the middle value is calculated low plus high by 2. If x is equal to middle, we have found the element, stop the execution and come out. If x is less than the middle value, you call the binary search. Repeat this from A to lower of to middle minus 1. The same step what we did. We are replacing the end here, right? Instead of replacing the end, we are calling the binary search again. So the binary search algorithm is repeated from the lower end to the middle end. Whereas if it is greater than middle, we call from middle plus high. So this part of the array, right side of the array or left side. So this will be again repeated. So if in this example, first we called from 0 to 6, right? So now we found out it is less than. So then we called from 0 to 3, right? So sorry, 0 to 2. Similarly, here also we will, in this we will call from 0 to 2. Again, we will repeat start from here. We will check whether it is same. No, it is still not same. So we will now call from 0 to 0. So this will be the edge case. If low is greater than high, we stop this and we check if the element is found. Okay, if none of this element is not found, then it is return -1, not found. Okay. So quickly, you want me to do an example of this? Can we quickly do a trace of this? So let's take a small example. So I'll take the same example, 2, 4, 6, 8, 10, 12. Okay, let's say we want to search for 12 this time. Okay, so 0, 1, 2, 3, 4, 5. So the first time low is 0. So low is equal to 0. High is 5. Okay, middle is equal to low plus high by 2. So 0 plus 5 by 2, 2.5, but we'll take the ceiling. So the middle element will be 3. We can even take the lower element also, but anyway, it is same only. So middle, let's take 3. Okay. Now, if x is equal to a of middle, so 12 is not equal to a of middle. A of middle is 8. So 12 is less than, sorry, 12 is greater than, 12 is greater than middle value 8. So if it is greater, which means this is the condition which is matching. So we repeat, we call binary search of the array. So we pass the value to be searched, the entire array, then the middle value, middle plus 1. So we search from 4 to 5. Okay, now we repeat the steps. Now low is, in this new recursion, low is 4, high is 5. So we check middle value is low plus high by 2. So 9 by 2, 4.5. We take the upper value. So A of 5. So A of 5 is equal to 12 and it is equal to the search element. So we have found the element. So we return the location, array location 5 and we come out. So this we come out and then we have found the element. So this is how the binary search occurs. Okay. So any doubts in this binary search? Shall I move forward? Any of you have any questions? Okay. So finding maximum element, we have seen examples. So I'm just not repeating this minimum maximum element. So we store it in minimum and maximum. We repeat if there is, we find an element which is greater than maximum, we replace that element. Similarly, minimum also, we find out if an element is less than, then we replace it. That is the min max in an array. So now one important is the growable array. I told you when the array is full, you cannot insert one. So you have to increase the array, stretch the array. So if it can store only 5 elements, if I want to store 10 elements now, then what I have to do, I have to copy the array completely in a new place with the new size of 10. Okay. So it is like we have a 1 BHK house. It is not sufficient. We have more people in our family. Then we want to go to a bigger house. So we shift all our things from the old house to the new house and we buy a 2 BHK house, right? Same way, in an array, we have 5 elements. We want to store 10 elements now. We buy a bigger one. We remove, discard the older one. We get a newer one. So increase the size by a constant or double the size generally and copy all the elements. So a new size of the array. So from I is equal to old size of the array, you copy all the elements in the new array and then you add, you increase the size of the array. So that is a growable array based stack. So the array implementation is simple and efficient if it's like simple operations. But if it is a growable stack, you can see that it, so it is better. Growable stack will take a lot of time, right? You have to copy the entire array from one place to the other place. So it's better always to calculate the maximum number of elements we might need in an array and kind of place it so that we don't have to kind of repeat this again and again or increasing the array, etc. Okay. So abstract data type is a concept which I wanted to brief you. It is nothing but a logic description of what a data type contains. It talks about how the data is stored and the operations that are allowed. And it is an abstract version which is not dependent on any implementation at all. So abstract data type is a method of achieving abstraction in the data structure and algorithm. So it is model plus operation. It describes what each operation does. It is independent of the implementation. Okay. So typical operations on a data can be add, remove data, ask questions about the data, all that. So simple abstract data types are stack, queue, vectors, list. All these are linear data structure. So in this class, we discussed about array. In the next class, we will discuss about stacks. Okay, so the next, there will be a lab session next week. So you will start implementing the arrays in C programming, and then we will meet for a week later for the stack. Okay, any questions? Is it clear what I have explained today? Binary search, array traversals.
Yes, ma'am.
Okay. Okay, then if there are no other questions, then thank you all. We'll meet again in the next session. Bye.
Okay, thank you, ma'am.
Thank you, ma'am.